Testing. I think I should be live. Just give me a second, make sure everything is live. Also, if anyone is already here, please put in the chat that you can hear me and see me. It's always good to double check. And yeah, it looks like there's already some people here. Awesome. And we'll get going here in just a minute. Let me make sure, again, everything is streaming in the right places. But while we wait, how is everyone doing today? And if you want to throw in the chat, maybe where you're watching from, that's kind of always fun to see as well, where everyone is tuning in from. I'm in Seattle, Washington, USA. Kelsey said they can hear me. Great. And again, we'll wait just a minute for a few more people to arrive. Then we'll go through some intros and a little bit about what we're going to cover. And then we're going to do a lot of hands-on stuff today, which hopefully that's what you're expecting, what you like. Someone said they can hear and they're watching from Chicago. Awesome. Welcome. And I want to go visit Chicago. I've actually never hung out there yet, but it looks cool. Looks like a cool city. I'm going to just paste a couple links in the chat. If you're watching on YouTube, everything you need to do to follow along is going to be in the description below. Don't worry about clicking on them right now if you don't want to. But a few things that we're going to do today when we get to the hands-on part is you'll want to have a free YLabs account. There's no card or anything required. So I think you just have to verify your email and you're good to go. And again, I'll bring you up these links again a little bit later when we get to the hands-on part, but I'll just also share them now if you want to kind of get ready. And then we're going to use Google Colab today to run code if you've never used it before. It's essentially Google's way of hosting a Jupyter Notebook. It's a really cool tool. I love it. I actually use it all the time. And then also just share a link to our YLogs repo, which we're going to be using today as well, which is an open source AI telemetry and data logging library. And also we have a new library, a newish library that you can use to monitor and get insights around large language models. So if you are working with LLMs, I know many people are, or you're at least experimenting with them, go check out that library as well. And then also there is a Slack channel. So if you want to stay connected after this event and ask questions there, that's going to be the place to do it. During this event, go ahead and just put your questions in the live chat on YouTube, or if you're also watching on LinkedIn, I should be able to see both of those. And then real quick, I will just share the links over on LinkedIn because I don't think it shared over there. So give me just one more minute and then we'll go ahead and get started. But again, I saw a lot of people join in. Throw in the chat, how you're doing today, maybe where you're watching from. Maybe if you want to give a little bit of context around why you're interested in learning about ML monitoring, that would be great as well. Do you have models in production already? Or are you just looking to kind of learn about it? And almost done sharing these links. Has anyone been working on anything fun? Any fun machine learning projects? Someone said they're watching from Brazil. Someone said St. Petersburg, Florida. I used to live in Melbourne, Florida. If you know where that is, it's about an hour south of Orlando on the coast. So I've been to St. Petersburg a few times. There's some cool stuff over there. Someone said they're building an ML project from scratch for their company. So monitoring is a key component. Awesome. Yeah. And if you, I'm always interested in hearing more about projects and stuff. So even if you don't want to share here, if you want to join the Slack channel or connect with me on LinkedIn, you should be able to find me under Sage Elliott. I always love hearing more about projects. And then if you have questions around ML monitoring specific to your project, would also love to answer them if you don't want to ask them here. So let's go ahead and get going. I see quite a few people here. Welcome everyone. And again, if you just joined, feel free to say hello in the chat. It's fun for me, but also for everyone else attending, I think, to see, other people are watching, maybe a little bit about what you're working on, where you're watching from. So this is Intro to ML Monitoring. We're going to learn how to get started with ML monitoring and AI observability. We're actually going to cover a lot today. The this workshop is hopefully a super friendly introduction to ML monitoring. So it's kind of designed where there's no previous experience expected, but definitely knowing Python and machine learning concepts will be helpful. But if you don't know them too well or you're kind of new to them, don't worry. I'm going to walk through everything, and feel free to ask questions in the chat as we go. First, we're going to cover some high-level concepts. So again, if you're new to ML monitoring, we'll just cover briefly kind of what it is, some of the stuff around it, and then we're going to go and do hands-on parts. So it'll be hopefully a fun combination of a little bit of slides, learning a little bit of theory, and then mostly jumping in and running code and implementing things ourselves, so you could take that knowledge and bring it back to your own projects later. And again, depending on your background, parts of it could feel fast-paced or challenging. That's totally okay. You'll get to keep all the code and stuff that you're going to run today, so you can always come back, kind of pick it apart, modify it, do whatever you want with it. And then also, like I said, you can ask me questions later in the Slack channel or on LinkedIn or something if you have any questions around implementing in your specific project. We can't learn everything in the hour and a half or so that we'll probably be going through today. And just a quick part about the agenda. So we have a lot to cover. And I know not everyone can always stay for like that full hour and a half or 2 hours. So the first kind of half of the workshop, the 45 minutes or 60 minutes or so, depending on how many questions there are, we're just going to do a quick intro agenda, which we're doing right now. We're going to do the slides like I talked about. That's going to kind of recap some of the theory and stuff. So no matter what your background is, hopefully you'll feel pretty comfortable as we go. And then we'll go through the notebook and implement stuff around looking at data drift, machine learning model outputs, and performance. And then, so if you stick around for that first half hour or so, you'll learn a lot. And then we're going to go into a little bit more of the advanced concepts like bias tracing and explainability, and then using the just open source library to do some things like data validation in your Python environment. So quick introduction. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. We build tools around AI observability and ML monitoring. We're going to see some of those in action today. I shared the links in the chat, but they're also in the YouTube description. So if you want to check out the open source projects that we have, go to the GitHub and give us a star. We always appreciate a star for the open source work. And for about the past decade, I've worked in software or hardware, mostly with startups, a lot of them in Seattle, Washington. But like I'd mentioned, someone else said they were from Florida, St. Petersburg. And I used to live in Melbourne, Florida before moving over to Seattle like 8 years ago. And I love making things with technology in general. All right, so I know a couple people already posted in the chat, but I really think it's fun to hear a little bit more about the audience. Where are you watching from at a bare minimum? It's kind of cool to see. I see some people already shared in there. And then also if you want to throw in why you're interested in machine learning monitoring, that's always really great to hear too, whether that's you have a project, you've heard a lot about monitoring, maybe you have models in production, but you actually don't have a system set up other than you may be manually checking on it. So take a minute, throw that in the chat. And then also there's an introduction channel in the Slack channel. So if you want to join that and say hello in those channels, feel free to do so we can stay connected later. Also, I'm not sure if my voice is getting a little scratchy. I've been talking a lot this week, so my voice might be wearing out. So I apologize if that does happen. Someone said San Diego. Someone said they're watching from Wales, UK. That's awesome. It's always fun seeing how many people watching from all over the world. I think it's really cool. Someone said in Bay Area, Silicon Valley. Awesome. I want to go back to San Francisco soon. I've only gone like once in the past year, and I used to go several times a year. So I'm excited to get down there more. And there's so many cool AI meetups and events going on down there. And they have great food. I love going down there and eating the food, obviously. All right, so quick setup again. Again, the links I shared earlier, you should be able to go back and click on those, and we'll cover them again when we get to the hands-on part. But for today, you really just need a Google account, which I'm assuming most people here already have, and that's because you're going to save a copy of a Google Colab notebook. Again, if you don't know what that is, don't worry. That's just going to be where we're running the code today online. So you don't really have to do any local installations of libraries or anything right now. And then the only other thing is you'll want to create the free YLabs account. Again, there's no card or anything required, so it should just take a few seconds to click there, sign up. I think you have to verify your email, and then that's it, and you'll be good to go to run the rest of the workshop. And we're going to be using Google Colab, like I mentioned, to run the code. We'll be using scikit-learn today for training a machine learning model. Then we're going to be using YLogs. I shared the GitHub link to this earlier. This is a AI telemetry open source library, and then we're going to be using a YLabs platform to look at some data. And we'll also be using SHAP, which is a library for model explainability. So we're going to get some metrics about that and see how we can tie that into our ML monitoring. So what is ML monitoring at a high level? This is kind of a architecture, a system architecture diagram of what it might look like. So you have your data infrastructure, where you'd probably be training your model. You have your model deployed and you're streaming data in, getting predictions on that. You have a AI telemetry library in this case, which is we're going to be using YLogs for this, and we're going to be collecting some data around the input data to your model as well as output from your model, and then we're going to take that data, put into some sort of system where we can aggregate all those statistics. We're going to store them over time, and then we can kind of visualize them, forecast things, query it. We'll see some of the explainability piece, and then set monitors. So if something does go wrong or something changes a lot with our input data or output data from our models, or performance degrades over time, we can do something with that information. That could just be, looking at reports and dashboards to understand how our different models are performing. We can get alerts and notifications, so we can go manually drill down if something did go wrong, or you can trigger workflow. So I always love building out, usually I always think of it as like a MLOps kind of loop. When you deploy a model, building the model is usually not the whole thing about making it ML application. So you deploy the model, you're getting data in that model. That data is probably changing over time. You can see it when that data changes over time, then have other people go in and like annotate that new data, retrain or train a new model with that new data, and then deploy that new model out. And maybe even before you deploy it, you want to make sure that that new model is performing better than the old one. And you can kind of do that in a really cool kind of automated way using triggers and workflows. And we'll talk more about YLogs in a minute when we get to it, but I'll just mention the way YLogs works here is we actually just collect summary statistics of your data. So no raw data in this case is actually leaving your infrastructure here. It's just like this privacy preserving summary statistics that we can use to still catch all those things like data drift and data quality issues. But it's a neat way where you're not really passing whole raw data sets, which can be really big, but they can also contain data that you don't want to share outside of your system. And YLogs has a cool way to kind of work around that. And we'll see what this looks like in action in a little bit as well. So why do we need ML monitoring? I've said some terms already, and you might already be familiar. In fact, if you've put a machine learning model in production before, you've probably experienced some of these issues. So with the model inputs, you can often experience something called data drift. I kind of like to think of this or explain it as, the input data to your model that's now deployed maybe no longer really matches the distribution of your training data set. So if you trained everything on some type of data, now you're getting new data coming in, and it has some sort of variation where your model may not be performing as well. And again, we'll see this in action when we get to the hands-on part as well. Of data quality issues, this can really range from all sorts of things, whether, if your data is manually inputted, if you have a camera collecting images and there's some sort of issue with that camera, the images can become corrupt. You have model outputs, so your model over time can experience something called concept drift, where it no longer really maps to the real world values. And we'll talk about this in a second as well. And then obviously there's the other ones you might have heard of and used even when training your model, like accuracy, recall. But then also we'll see this in action later today as well, but measuring for bias and fairness in production. So how is your model performing on certain segments of your data? And also explainability, like what are the features in that data set that are kind of causing your model to make those predictions. Oh, and we have a saying, bad data happens to good models. So a lot of the times you can, evaluate your model all you want before you put it in production, and that's great. You should definitely do that. Once you put it in production, chances are usually pretty high that you're going to be experiencing data that shifts over time. Has anyone put a model in production and experienced anything like this so far that's in the audience? And that could be any type of data quality problem or data drift issue. There's so many different things that, can happen. So quick example on data quality. that I mentioned, I think one already, but like an input sensor could be damaged, causing bad data. Data was manually entered incorrectly. A camera is pointing in the wrong direction. So a lot of times, even if you're deploying stuff in a very controlled environment, things like change over time. Like I've had this happen where it's been like in an indoor situation. I've done a lot of computer vision before, so I might use computer vision analogies a lot. But it's in a controlled environment. We don't expect like seasonality changes necessarily. And still, like someone turns off a light or something like that you didn't plan for. There's always something that can go wrong and start causing some bad quality issues. Someone said definitely experienced degraded performance over time. Were you able to troubleshoot and figure out why? Like, was that the input data was drifting? Was there something else at play? Would love to hear your experience about that, and maybe how you found out that it was even happening. So a lot of times, you want to set up this monitoring so that you find out quickly, and hopefully much quicker than like if you're doing an online store or something like that. You might not find out until you have customers let you know there's a problem. So hopefully with ML monitoring, you'll catch if there's an issue happening very quickly before it really makes an impact to your business or with customers. Because the worst way of kind of finding out is when someone else that you're building a product for lets you know. Data drift example. So again, we talked about this, but this is the input data to your model. And some common issues here are seasonality changes. So again, going back to a computer vision analogy, maybe you trained a object detection model on some sort of animal, and all that data was in the summer. And so like the grass was all green in the background. And now you're using that same model in the winter, and let's say there's snow on the ground. So now instead of the animal being on a green background, it's on a white background. That data looks very different to the computer vision model. And there's definitely a chance that with that new kind of pixel color going on into your model, that it may not be performing as well. It's common to get new groups of users. So you might deploy a model somewhere. Again, just online store as an example, you have a certain segment of users that started using your product, and then a year later you got a lot more users. That's awesome. Your business is doing well. But now they have different behaviors than your previous users. So if you trained a model kind of on that user group, it may no longer be making the right product recommendations for your new group of users. Or consumer preferences have changed. People change all the time. Maybe we didn't want maybe we don't want what we were shopping for like 10 years ago. If you had a model that old, and you'd probably want to be updating it. Again, if you have an example of data drift that you've seen, throw it in the chat. One example of concept drift. So the incoming data isn't necessarily changing, but the output no longer really matches the data in the real world. And one example I like to talk about is the housing market. So if you trained let's say it was a really simple model in this case, and you're just looking at the number of rooms and square footage of a house, and you're predicting a price on it. Well, if you trained that model 5 years ago, and then you had that same model predicting housing prices right now, do you think it would be right? Definitely not. Prices have gone up a lot in the last 5 years. So in this case, you'd want to retrain that model with something as dynamic as housing prices and changing so much over year. So it would be outputting something probably much lower. You'd want to fix that by retraining the model with the new labels of the current prices. And then we'll go pretty quickly over this. We'll see this in action, but you can detect bias in production. So you might have seen several years ago, there's a whole bunch of different use cases like this, but several years ago, I think it was a big tech company that had a credit card, and they're using some sort of algorithm, to approve or disapprove someone getting that credit card. And there's a big problem with gender. So I think all the men were getting approved and a lot of women were not. And then if you were able to segment that data into those two groups and see how that model's performing over time on just those two, you could see in production, our approval rating for this group was so high. Why was it so low for this other one? And then that allows you to kind of drill down and figure out why that was happening in your model. So we'll look at this too, like how you can have a model in production, segment your predictions and data into groups like that, and then figure out if it's being biased over time. Because it's not like they had that data, I hope, encoded into their features that the model was making prediction on. There's some other features, and it was able to extract that somehow. And then model explainability. It's a field in machine learning where you can kind of extract metrics to attempt to explain why the model's making those predictions. Sometimes this is easier, sometimes it's a little bit harder. Here's an example with computer vision, and I think this is just classification here, and it's recognizing that it is an elephant, and it's highlighting the pixels that are most important for it making that prediction. So the classification algorithm probably looks at like this head shape and trunks and the shape of the elephant body here, and then it's saying it's an elephant. Here's an example of tabular data set. This is actually a housing data set here. And what we're doing here is using SHAP to extract what it thinks the highest important features are for the model. And again, we'll see this in action in a little bit later as well. So just to hammer home, we just have a few more slides left, and then we'll get to the hands-on part. Just to hammer in your head how to analyze an ML application, especially if you've never done it before. So one, it's a ML application. Do you probably have several things going on? You might have a feature store, model endpoint, you're making predictions, maybe you're getting ground truth, and then you might have some sort of KPIs that you're looking for that model to do. So you want to establish where a change can occur. And that can be really anywhere in your pipeline. It could be the direct input. It could be transformations on the data. Like you mentioned, there's data quality issues, and that can happen kind of anywhere in the pipeline. But as a bare minimum, if you're just getting started, I always recommend looking at the direct inputs to the model and look at the direct outputs of the model. So just the inputs and outputs can give you a lot of information, and we'll see that first today. And then obviously, if you can get ground truth later or in a sample of your data, that's going to give you some good information as well. The next thing is, so you're analyzing change in the application. You should establish what a good baseline is for that. And we'll see this again today. A good way to get started, though, is if you don't have a lot of production data, you might want to take your training data, look at any new data coming in, and then compare the distribution of both those data sets, the new data and the training one. And if your new data falls well outside of that distribution of your training data, again, there's chances that your model may not be performing as well on it. And then when you do that, you want to select, what you're measuring for. So if you're just looking at input data, you might want to do data drift detection, which is what we're going to set up here in a minute. And with that, you would choose something like a distribution distance. So when the distribution of the input data changes a certain amount from the training data, trigger an alert or some sort of workflow. But you can also do things like look at missing values, data cardinality, or if you have the ground truth, you can just be looking at overall performance degradation. And I mentioned Langkit before, so today we won't be talking about large language models, but I know everyone loves talking about large language models, myself included. And I'll just link one more time to our GitHub repo for that project. And I will be doing a workshop on this soon as well, probably in a few weeks. So stay tuned if you want to go through kind of another hands-on workshop, but using Langkit to monitor large language models instead. All right, so that is enough slides. Let's go on to the hands-on portion. I'm going to copy this link into the chat again, but if you're watching on YouTube, everything should be in the description that you need. So I'll give everyone a moment to open up this link. Let me know if it doesn't work. It should work. I've tested it a fair amount in Incognito tab and everything, so hopefully everyone should have access to it, but just if it doesn't for some reason, let me know in the chat now. And then again, you'll want to sign up for a YLabs account if you don't already have one. And then also, if you want to get some swag, I have a little survey here that you can fill out. We actually have some cooler shirts. Usually I'm wearing one when I do the workshop, but I'm not today. But we have mugs and also this really cool YBot stress ball that everyone loves. I love it too. All right, so I'm going to give everyone a moment to open up those links, create that YLabs account, and then you should open up the Colab notebook, and you should see something like this. I'll zoom in. Let me know if that's good enough. If you need me to zoom in more, I can probably do that as well. While everyone is opening up that link, I'll mention your next step should be go to File, save a copy in Drive. I'm actually going to do that myself here. And this is going to create your very own copy of this. So you can go bookmark the original link if you want. And this is your copy. You can change anything you want in here. So don't feel like worried about breaking the code or anything like that. In fact, I always encourage it to play around with everything. And once you have your own copy, so again, go to File, save a copy in Drive. Once you have your own copy again, we'll get to the YLabs part a little bit later, but go ahead and create that free account so we can get an API key and link this to the platform. There's a few other useful links in here, YLogs GitHub again, and then also the Slack channel, which again, I recommend joining, introducing yourself there, and asking questions after the workshop. All right, so Google Colab, I mentioned a little bit earlier, is essentially Google's way of hosting a Jupyter Notebook, but it's a little bit more than that. It gives you a whole computing instance behind the scenes, and it actually has a really cool feature where you can select a GPU. So if you don't have a GPU and you're getting into deep learning or computer vision or something like that, it's a really great tool to get started. And if you've never used a Jupyter Notebook before, it's a really popular tool in data science and machine learning where you can write code, kind of documentation like the text you'll see throughout this, and you'll see the output all in one place. So it's a really cool way of kind of writing code, seeing visualizations, and being able to document it. So we can go ahead and run this first code cell. This is going to initialize our instance. You can run code cells by hitting this little play button off to the side, or when it's selected, you can hit Shift-Enter. It'll run the code cell and then move to the next one. So you can kind of keep hitting Shift-Enter if you want. So if you don't see me hitting that play button, I'm hitting Shift-Enter, which is what I often do during the workshop. Like I mentioned, it's a whole little instance here. So you can actually run terminal commands, just put the little exclamation mark at the beginning. And here we're just listing, all the samples in the directory or all the what's in the directory. And in this case, there's a sample folder. And if you want to visually explore anything, you can also open up this little folder icon here and then explore the files. So let's go ahead and run this pip install. I didn't mention, but Google Colab also comes with a lot of popular data science and machine learning libraries already pre-installed. But we have to install YLogs in this case because we're not in there by default yet. Sometimes that's a great feature. Sometimes you also want to update those libraries. And speaking of, I think we still want to restart runtime. I think this actually might be fixed now because, like I mentioned, it comes pre-installed with certain ones. So it had an older version of Pillow, which is a image library. And I think, I don't think it conflicts anymore, but I'm going to go ahead and hit this restart runtime. I'm pretty sure we're good, though. So if you don't do that, I think you'll be fine. I'm going to do it as a precaution here. If anyone does run into an error later that says, like, pill is not compatible, that's because you needed to restart the runtime. But I think we're going to be OK now. But it always varies. If you're watching this, Google Colab may have updated that version of the library again. So let's go ahead and import the libraries we're going to use. We're going to use YLogs, NumPy, Pandas, DateTime, OS, and then we're going to use a train test split, and we're going to use the Iris dataset as the starting point. Don't worry if you've done machine learning before, you've probably used the Iris dataset before, but this is going to get a little bit more interesting. And again, if someone in the chat wants to let me know you were able to open the notebook and copy it, that would be great. I'll wait a minute for someone to let me know that everything is working. All right, I think it seems to be good. If anyone has an issue, let me know. All right, so we're going to go ahead and import our Iris dataset. Yep, okay, cool, yeah. People said it's working. They're able to open the notebook. Awesome. And if you've forgotten already, our Iris dataset is 3 classes. So these are 3 classes of flowers. And then we have 4 features that we're going to be making predictions on and training our model. We have sepal length and petal length and width. And here, I won't spend too much time on this, but here we're training a k-nearest neighbors model. We're importing neighbors from scikit-learn. We're going to be looking at the closest 5 neighbors to be making a prediction. We're assigning the features to X, the target labels to Y. Then we're doing train test split. So we're just going to make a training data set to train our model on, and then we're going to do a quick test to see how it performed on the leftover data. Someone said it's getting a warning on the Colab notebook. Did you save I'm not sure what your warning is, but I recommend saving your own copy in Drive. That could be the warning. Or it could be the restart runtime warning, which if that is the case, you can go to this whole runtime drop down and hit restart runtime, and then just make sure you run all the code again. You don't have to run the pip install, though, all the code after the pip install. And then our train test split, we're passing in the features, the target variables, and then we're just saying leave 30% of the data for test, and we're kind of shuffling it in a random state. And then stratifying it just means we're trying to get an even distribution of all those classes in our training data set. And then this is where we're actually training the model. So we pass in the train and the target values, and then we're going to make a prediction. And I forget if I already ran it. I'm going to run it again. So just based on that training data set and the 30% of test data set we left over, our k-nearest neighbor model right now is at 97%, basically 98 accurate on that type of data. And just as a bit of intuition, and spoiler alert, this is going to come in later when we see something going on with our data and models. Just as a recap how a k-nearest model kind of works at a high level, as you have a new piece of data that comes in, and we now trained our model. So it's, in our case, it's going to be looking at the closest 5 neighbors. But let's say this black dot here is a piece of new data, and this one is looking at the closest 4 neighbors. And it sees that 3 of them are versicolor, 1 is virginica, and it's going to predict that, well, the majority of the closest neighbors to me are versicolor. It's going to make a prediction on that class. And we'll see why this is important a little bit later. So let's go ahead. This is another kind of setup cell here. We're just importing several CSVs. So this is going to be our batches of data. We're going to kind of simulate that we're running a model in production for 7 days. So I just have 7 CSV files here, and we're going to use one, each one is kind of a day a little bit later. And then we're separating the targets. So it's just those feature values. And then basically at the end, we end up with a data frame list here. And if we look at one of those data frames, one of those batches, we can see that this now contains all those features that we would expect to be in our Iris data set, but we have a whole bunch of them now. So this is kind of a fake Iris data set that we're using to simulate our model being in production. So again, we have all those features: sepal width, length, and petal length and width. And you can see the numbers all over, and I think most of them are 150 rows. All right, so let's create a log of this data with ylogs. So like I mentioned before, if you were here at the beginning, ylogs is an open source library for logging data pretty much of any kind. So you can, today we're using tabular data. You can actually use it to log image metrics and language metrics. And with ylogs, you're able to generate a summary of their data set. So we call these profiles. And like I mentioned, they don't actually contain really the raw data of your data set anymore. And we'll see exactly what this looks like in a second. But they're just summary statistics of your data. So in this case, they're tabular. You can kind of think of that as being like the min, the max, the mean, etc. There's a little bit more to it. But just with that kind of fingerprint of your data set, we're able to do all the things that we want, like detecting data drift and data quality issues without using your raw data. And this is really important for a lot of industries. So if you're monitoring data in a healthcare application or sometimes fintech, you don't want to, or you might not be allowed to send your data out of your own environment. And just with this kind of statistical summary, it doesn't really contain any of the sensitive raw data that people are worried about. And they're super lightweight. So instead of passing a whole data set out, you have this really efficient profile that you can pass, over a bad internet connection or anything like that if you're using it on an edge device. So a lot of really exciting stuff about this really efficient profile. And ylogs integrates with almost any library that you're probably using in your ML Python stack. We have a lot of official integrations, but also it just works as long as you can pass data in like a dictionary format. So almost any type of library, if you can get your data out in a dictionary or a data frame format, you can use ylogs for it. And it's also customizable. So if you want to add in user-defined functions for different metrics and stuff, you can totally do that as well. So let's go look at what a profile looks like here. So all I'm doing here is I'm passing in that first batch we saw before. So there's like 150 rows, I think, in there. We're calling y.log, and that was a pandas data frame in that case, but it could also be a dictionary. And then we're getting a profile view from that, and then we're looking at that profile view in pandas. And so you get this really long pandas data frame here, but this is everything that's contained in the profile. So we see the cardinality estimate on this is 42 for petal length. We have all those columns off to the side here. The cardinality just basically means there's about 42 unique different values in those 150 rows. So we can see our row count was 150. You can scroll over. I won't go through every single metric here. We'll see this visualized in a much better way in a minute, but just mentioning that you can scroll through here and kind of see all this data. And you could access it, and we'll write unit tests a little bit later with ylogs, but you could do anything you want with this profile locally in your environment. But we're going to go ahead and look at how we can take these profiles, send them, in this case, to YLabs to visualize them more easily and set up easy alerting and use it for AI observability. But again, you can check out more about ylogs on the GitHub, and there's a whole bunch of examples with different integrations and libraries. So there's just 3 pieces of information we need to get from the YLabs platform before we can upload our data to it. So did anyone make that YLabs account already? If not, the link is in the description below. Once you have a YLabs account, you should be able to go to a page that looks something like this. You might not have these toy projects. There might be some other starter ones that go in there by default. And what you want to go do is you could either hit this create resource button, and this will bring you to this page. But no matter where you are, you can also always go to settings off to the side here and go to model and dataset management. We want to get to this page. So real quick, I'll just pause and ask or wait a second so people can create the count if they haven't already. But if somebody wants to let me know that they were able to create the count and get to a page that kind of looks like this in the chat, that would be great. Let's see does this look a little better maybe? All right, so someone said they were able to create the count. Awesome. I'm gonna shrink myself a little bit to make it hopefully a little easier to see the platform. All right, so I'm gonna go to that resource page. So again, you can hit create resource if you're on this page, or always go to the settings and go to model and data management. I'm gonna go ahead and delete these 2 models that I have. So you again, if you have a pre-made model in there, you might want to delete them as well, and then we're going to create our own today. So I'm going to hit delete and hit delete here, and then I'm going to create a new model. So I'll just call this Iris. I'll call it a ML workshop. You can call it whatever you want. And then this is important because it's going to be a classification model. We want to go ahead and select classification when we're making a new model. This is going to allow us to give us the proper performance metrics later. So you can always come back and change this too. If you don't select the right one right now, you can hit edit and then change the resource type. But I'm going to go ahead and hit add model. And then from here, we have some numbers off to the side. I want to grab it for my latest one. So my model number is model 242. Yours will probably be much lower unless you've already been using YLabs for a long time and experimenting with a lot of projects. But you'll probably be like model 0, 1, 2, 3, etc. So I'm going to go back to my notebook, copy that information, and I'll paste it in here. Make sure that you don't accidentally paste any spaces or new lines into your variable here. So I just want to have this text, and then I want to go get my API key and org ID next. So from this page, I just click over to this access token. So I've already created a model. I'm going to go get some other access tokens here. I'm going to go hit access token, create an API key. Oh, I have too many. I'm going to delete a couple. You shouldn't have to do this. Yeah, someone said on the project dashboard it was only 1 model. Great. Yeah, so it doesn't matter. We're going to create a new model now. It's okay if you had 1 or 2 before. So I'm going to create the new access token now. And again, you could call this whatever you want. I'll just call it workshop. And then it gives me my access token up here. So I'm going to copy this back to my notebook, go to the API key, paste it in. Again, there's no spaces or new lines. One more piece of information that's on the same page is you can get this org ID. It's here. It's also located right over here. And then I'm going to copy this in as well. And again, make sure there's no spaces or anything. Mine looks good, so I can go ahead and run this. And got a green check mark there, so everything ran. I set up my API key tied to my model ID and my organization. So I'll give everyone just a minute, and I'll go through that again. I know sometimes I'll go through very fast because I've done it a lot. I'm very familiar with the platform. So no matter where you are, you can hit this YLabs icon that will take you to the homepage. Probably the quickest way to get to where you want to go is just hit this Create Resource button here. Type in a new model name. Make sure you hit Classification Model, and then get that number that's over here. That's what we want to put into that model string. And then from here, once you have that, go to Access Token, type in a new name here, copy that new API key that will pop up, and then copy in the org ID. And again, I'll give everyone just a few seconds or a minute here to do that if you haven't already. And as always, if someone wants to let me know in the chat that they did it, that's always great to hear as well. All right, I'll keep going. But if you want me to revisit this, please let me know. And hopefully more quickly than later, just so I don't go too far down the notebook and have to come back up. But I think you could probably figure it out. I've gone through it twice. So let's go ahead and import the YLabs writer. And then let's write a single profile. So it's really just a few lines of code here to create a profile like we talked about, and then send that profile to YLabs. So go ahead and run this code cell. We're initializing our writer. We're profiling our data just like we did before. So it creates that profile with the summary statistics that we looked at. And then we're passing that file in, or that profile in, and writing it to YLabs. So if I go back to my platform, and again, I'll hit this YLabs icon. So it takes me to the home page. And I can even see now it says there's 4 inputs going on here, and that a profile was uploaded. I'm going to go ahead and click in on this though. And we again see some features in our dashboard. This summary feature kind of gets more exciting as you upload more data. But let's go ahead and I can look at this profile tab. Oops. Actually, let's go look at the input tab. It's usually more exciting. So we go to petal length and make sure. But that was my bad. Okay, so this can happen sometimes too. I was playing around with dates earlier. It might have already been selected for you, but if you go in to your input page here and you didn't see anything, even though you ran that code cell, it's in my case is because I had a wrong date selected and that profile wasn't in that date. But you can always hit this little button here or link where it will reset the view here to the batch profile lineage. So this will reset all the dates up here. But this is cool, a really great feature. If you have a lot of data and you want to explore what somebody looked like, months ago or a year ago, you can change those dates here. But this will reset it. So now I can see this isn't super exciting yet. It's going to look more fun in a minute, but we can see we have one profile here. So all those statistics that we kind of saw, where we had the max, the min, the median, etc., the percentiles, those are now logged here in a single profile for a day. Now let's go back. And again, I just want to show the single profile, how easy it is to write up, because often you might be doing something like this. If you have a model in production, you're getting the input data, model outputs, and then writing a profile with just a few lines of code. And then I can run this code cell below. We're doing something very similar, just like we did before, except for we're looping through all of those data frames in our list now. And then we're changing the date time for each data frame in there. By default, if you write it up like we did before, the date and time is going to be the time that you write it. But we want to loop through, and then we're going to subtract a day for each one we loop through. So this is kind of us simulating a model being in production for like a week. And then we're doing the same thing. We're calling y.log on that data frame. And then we're resetting the timestamp though this time, and then we're writing it up. So if I go back to YLabs now, and if I can refresh my page. And if it doesn't, again, automatically show up, you can hit this profile lineage if you change the dates. And now we have this more interesting time series view of what our data looked like in a week. Does this look interesting to people? Like, what do you think is going on here? So, and if I hover over the data, again, it might be a little hard to see on my screen, but if I hover over the data, you'll see the kind of those, the information in the profile listed here. And so I can look at each day And let's just say, like, we could look at all these values, but let's just look at the median in this case as 1 to kind of troubleshoot our data or look at our data that we've been logging. So we're going to see the median on the first day is 4.2. The median on the second day is 4.3. The median on this day is 4.2. Median on this day is 9.2. That's a huge change. Now we can see this area looks interesting. We can see that this yellow gives us the upper and lower bounds, and we can definitely see that it has a max value, an upper bound of way higher than most of the other data, almost 33. But the median itself isn't that much higher. It's 5. And then this is interesting. This profile, everything is 0. What do you think that means? It means all of our data was 0 in that case. So the min, the max, everything is 0. And then this last day, the median again is around 4.2. So just looking at this data, visualizing it in this way, we can kind of see something might be going on probably in our data set on these dates. So 7:30, it went way up. This is an interesting day, even though the median isn't maybe crazy out of bounds from everything else. There's definitely like a max value that maybe shouldn't be in there. Like, do we think an iris petal length could go all the way to 33 centimeters? I don't know. Probably not. That might be a misentered value. Maybe they meant to type 3. I mean, there's one that's all zeros. Maybe we should have a rule in place that petal length, should always be greater than 0. But right now we don't have any data quality checks, and we will look at how to do this a little bit later with YLogs as well in your Python environment. But right now there aren't any data quality checks, and so it's just everything's getting logged in here. So we can see there's definitely something going on with our data probably here. And it's great that we can visualize it and visually catch it, but we probably don't want to always have to trust us looking at this dashboard. Like, you could go look at every hour, every day, etc. But instead, what we can do is set up a monitor to catch when any of these big changes happen. So I'm going to hit this setup monitor button. You'll see it around in other parts of the platform. I'm going to click this one. And then we have some preset monitors here. You can also poke around in creating just a new custom one. You can even go into a configurations and adjust all the JSON, so you can really get like fine with what you want to tune and adjust here. But we're gonna use a preset one today, and I'm gonna hit this one that is data drift and model inputs, all non-discrete values. So it's gonna be looking at kind of just like numerical values coming in, and we're gonna go ahead and hit configure here. This will bring up a screen where we have some options. So here you could change, again, what you're looking for, like data drift, quality, etc. And then here we are going to be looking at the entire data set. Again, a little bit later in the workshop, if you stick around, we will go into how to segment your data so you can actually set up monitors on just specific subgroups of your data. And then here we're going to select the Hellinger distance that we want to monitor. I'm going to make this a little bit more sensitive. So the lower number that we put here, like I had set 0.7, that's basically saying if a drift distance of 7 happens, trigger an alert or a workflow. I'm going to make this a little bit more sensitive by lowering that number, but I could also make it less sensitive by hiring it. So, if I set up a monitor and it was going off all the time and I actually was like fine with the variation of data I was seeing, you might want to come and tune this so it's a little bit of a higher number. But here we're going to make it pretty sensitive. And then we are going to select a trailing window for now. We can actually come back. Actually, I think in the notebook, the next part is us uploading a reference profile. So by default, if you don't have a reference profile, you can look at basically how this data is changing in the last 7 days or 90 days, etc. One thing I like to do, like I'd mentioned before, is using the training data set as a reference profile. So you can look at any new data. Is the distribution different than that training data set? So we might come back to this in a second, but I'm going to go ahead and hit save. And I forgot to mention that last part. I'll go back real quick here. So you can also set up, what it does here. You can create a notification inside settings or a workflow, and then when it triggers, it will do that action. So let's go back to that input page. And I'll go look at, again, petal length. And let's go ahead and hit preview on this feature. And remember, it's just looking at the last 7 days of data, trying to figure out what days look, the most out of balance based on the last 7 days. And we can see that these 2 days that we thought were really weird definitely got triggered. And now if you zoom in again, you can actually see that there's a Hellinger distance score that's provided in there, that purple line. So in this case, the drift was super high, 0.9. This day, we said it looked interesting, but the median and et cetera, like most of the data wasn't crazy, but there's some that's out there. It definitely has a drift distance, and this is where we could tune our monitor to be more sensitive. And then this other day where it's all zeros, the drift also is, again, incredibly high. And that drift score is just saying, the data set on this day is way different than the data sets on the other days. And if I go back to my profile right below, I'm going to actually upload that reference profile real quick. And again, and that is just the training data set in this case. So if I close this preview, I'm actually going to go back to that monitor manager page. I'm going to edit that monitor that we already set up. And I actually do want to do that reference profile. So now it's going to be looking at that reference profile. And go back to inputs. And I'll hit preview again. And because I set it to that 0.6, it actually is triggered here now. And so all these days that we think our model might not be performing as well anyway, we don't actually quite know yet because we haven't looked at the outputs or the performance of the model. But we think there's something probably going on with our data these days, and chances are probably pretty high that our model's not performing as well. All right, so we're going to go in and look at outputs and performance next. Any questions so far, though? Was everyone able to run this? Does it seem pretty interesting and useful for looking at your data and your projects? I know some people said they were running it and I think uploading profiles. So let me know if you're able to kind of get to this page, even if you didn't set up the monitor yet. I'll keep going through the notebook here. So next we're going to be logging the output of our model. So we can go ahead and run this. This is actually just creating this is actually just adding the predictions to our data frame. So we're making predictions. We're also getting the probability score, and then we're just appending those to a data frame here. So if I run this part, now we can actually see in this data frame that we have all those features like we had before, but we also have the output class now here, the Setosa and the probability output. So now let's upload that data. And here we're just uploading the data, we're looping through the data frames again, but we're just uploading these two columns now, the output and the probability output. So very similar like we did before, but we're just targeting these two columns. And by default in YLabs, if you include the word output or outputs, it actually puts it into this outputs tab here. And then you can click on this. And we can see that our output here, again, on those 3 days, we know something. We started by looking at our data that looked a little funky on those 3 days. And we could say, well, the distribution of these predictions in this case are pretty even on most of these days, except for those 3 that we thought looked weird. Like this one is almost all one class. This one is more of one class than the other ones, but not quite as weird. And then this one, that one that was all zeros, that's all one class as well. And then again, the distribution looks pretty normal here. So just looking at the inputs and then the outputs here, like we could have probably a guess that our model's probably not making the right predictions if we felt that like, oh, well, usually it's a distribution around this, around these classes, and then these 3 look very different. Something's probably going on. And as a quick thing, I'll ask a question to everyone. Why do you think these classes are being predicted? Based on the data we saw, and as a hint, we kind of recapped how a k-nearest neighbor model works. What do you think is going on here? And someone asked, what is Hellinger distance? So there's different scores to measure data drift. And like you might hear of ones like KS test, etc. And they all kind of provide a different way of measuring distance between data changes between like one profile or several profiles from another. And a Hellinger one is a good one, I think, for categorical and numerical values. And if you actually go in to the monitor manager, see, I believe you can select different ones. So Hellinger distance is the one we often just recommend if you don't know exactly what you want to choose. But you have all these other ones that you can look into and see if that's going to be kind of better for your specific data set. But again, think of it way of looking at the change between two things, and it's a way of measuring that. So just on these outputs, it's funny because like this is all one class, this is all one class, and if you remember how the K-nearest model works, is you get a new piece of data, and then it's going to be looking at the closest, in our case, 5 neighbors. Well, we don't have any unit tests or anything or constraints in our data to model predictions. So if they're all 0, so if the new data point was down here, the 5 closest would always be Setosa. And then we saw there's ones where the values were much higher than the other ones. So again, it could be way off the chart over here, but it'd still be looking at the closest other data points. And so it would be predicting Virginica in that case. But it could be, values of 100 or whatever, hundreds, even though everything else fell in this distribution. And that's why it can be helpful to write these kind of unit tests for your data, which we'll see later as well. And we could also look at probability score and see that it varies on those days as well. Any other questions, though, before we move on? So I have one other kind of part of this first section. We're going to add our performance data in, and then I'll definitely pause a little bit longer there for questions. And then we'll go into the explainability part and the bias tracing. So just a couple more cells to run for this first part. And I just want to reiterate. So in the workshop here, we kind of did this a little bit of not a super weird way, but we were, running predictions from a pandas data frame. And then we added output to that pandas data frame. And then we kind of looped through in this way. But a lot of times in production, you'll actually just be doing something like logging the prediction values, or logging the input data and the output data at the same time. So you might just create like one dictionary, and then you just call y.log and push that up with the YLabs writer. Or you can use something called a rolling logger that we have, where you can kind of merge all these profiles together and then write them all up at once, like at a set interval. So just mentioning, this looks like a lot of code here. All we're doing through is looping through those days, kind of simulating 7 days, but really it's just a few lines of code if you're actually going to put this in your like web app or your ML application. So let's go ahead and do one more thing for this kind of first part of the workshop, whereas we're going to log our performance with the ground truth. So again, kind of like we did before, we're going to add the ground truth back in to our data frame because we had separated it out before when we imported those CSVs. Now we have a ground truth value, and we just want to log that up. So we're going to call this y.log classification metrics. If you're using regression, you can also log regression metrics. You would just change this out, and then we're going to pass up the ground truth and class output. And then again, we're looping through editing the time. So if I go back to the YLabs platform, go to this performance tab, we'll see some of these other tabs, actually all of them a little bit later in the workshop. But go to this performance tab. Now we have ground truth, so we actually know like what the accuracy was for our model on those days where we thought the data looked interesting. And we can see on all 3 of those days, our model did not perform nearly as well as it did on those other days. So, it was 90s, and then all of a sudden the accuracy jumped to 34, and then 46 on that day that had some of the high values, but some of the distribution was similar, so not quite as bad as the other ones. And then accuracy is 33 on the one that's all zeros, because some of them in those batches were those classes. So even it was just always predicting Setosa, right? It had a 33% accuracy. And that's why accuracy isn't always a good measurement for your ML models either. Like if you were measuring if someone was walking through an X-ray in an airport with a gun, 99% of people probably don't have one. So you could have a model that was 99% accurate, but then it fails when you actually want it to. But we log all those other metrics here too, like recall, F1 score, etc., that you'd want to measure. So far we've gone through, we looked at how to ingest and visualize input data and output data from your models, as well as performance over time. We saw how we can set up alerts on them to either, send you a notification or trigger some sort of automated workflow. And again, you can also create those monitors on other features. So we just did it for the input one here, but you could do it on like the accuracy metrics, or you could also do it on outputs. So you might want to set up alert, say, hey, if there's a big change in distribution between these outputs someday, catch that as well. And so one thing you might also want to do is when input drift is detected like this, and you want to actually investigate like the ground truth values and performance, like we already saw, you can actually learn a lot just by investigating like we did, looking at the inputs, looking at the outputs. But if you want to get that performance data, and to get that usually from production data, you're going to have to go annotate some data or have someone annotate that new production data, which is really cool because you can get performance, ground truth, but you also now have new data that you can train a new model on. So one thing I like to think about is always how you can set up that loop when you deploy a model, of deploy a model out, collect production data, usually re-annotate in some way, train a new model that's hopefully going to be better, deploy that model, measure if that new model was better. So you can actually do that with YLabs here. So if data drift is detected, you might use some sort of crowdsourced data annotation job, or maybe you have them in-house saying, hey, there's new data. It looks different than our other data. Please go label it so we can actually make sure that our model is performing well. And then you could get that performance data here, say, yeah, it definitely wasn't performing well. Take that new data, let's train a new model, and hopefully it does perform better. You could deploy that model. And then I don't think I have another one to actually compare in here, but you can actually compare those model metrics between two that are deployed, and then see that, yes, this new one is better. Let's go ahead and give that one to the customers. So a lot of really cool stuff you can do with tying monitoring into your MLOps and AI kind of workflow. So again, like I said, I'll pause here. We're going to go into kind of part 2 of this. But I just want to ask again if there's any questions, or if anyone just wants to say like, oh yeah, it worked and this seems really cool, or something like that in the chat. Chat's been a little quiet today, so there's some people that have been talking, which is great. I always appreciate that. But yeah, what does anyone else think? I know there's still quite a few people here. Does it seem useful? Have you been in a situation where, you wish you would have had this before? And just for the next part, this section may or may not be collapsed when you copied over the notebook. So it says part 2 and there's part 3. You make sure you can open this up if you don't see that code that I'll be running. That's why. But yeah, oh wait. Yeah, what does everyone think so far? Pretty interesting. Any cool use cases come into your mind? Do you want to take this and deploy it right away and start looking at your data in production? Someone asked, could I discuss how I use these techniques in a larger computer vision task? Great question. And like I said, that's actually what I've used in the past. And I do a workshop on it. I don't have one coming up right now, but you can find a recording of me actually doing this in a computer vision scenario. So in one case, it depends on what type of computer vision model you have. You need to figure out what metrics you want to track. So one thing out of the box that you can track, and that actually is usually pretty good for some data drift and quality issues, is out of the box, YLogs has a log image function built in, which will extract some metrics around images. So by default, I forget them all off the top of my head, but for example, it's like pixel brightness. So if you had brightness of, a certain degree for most of your data, and that's what your model is trained on, and then all of a sudden everything got way darker, you could catch that. And some real world use cases I've seen where this comes in is not only, like I'd mentioned, someone turning a light off in a factory, but backgrounds often change, whether that's if you're looking at, I think I had an animal example before, but one example I've actually ran into a lot is if you're in a manufacturing setting, and let's say you're, classifying an object, and they had a mat and it was like that blue color, and then they changed that mat out to a black one without telling you, chances are your model's not going to be performing as well. It's going to look very different. And that's actually what we go through and show in the workshop. Just by extracting those not language metrics, image metrics, you can log them just like you do here, and then measure anything like that for drift. So that could be, again, those pixel values. It could be a custom metric too. So if you're doing something like bounding boxes, it could be the amount of bounding boxes that are shown in a frame. how large those bounding boxes is. So maybe you're always expect an object to be, a similar size in your use case, and it gets really small or really big. That can tell you something. And then also, maybe color distribution, but just within that bounding box. So if you're detecting cars and all your training data set had blue and red cars, and all of a sudden a green car comes back, it could be, well, the distribution of this color doesn't really match anything else I was trained on. So that's one kind of high level use case. And it's also cool. You can use ylogs on edge devices as long as you can run a Python environment anyway. So like I've actually used it on a Raspberry Pi or a Jetson Nano. You can install it on there. You can log the image data there. And then because those profiles are so lightweight, you can usually pass them off pretty easily. So I've been in instances before where you have an edge device with computer vision. Trying to get a lot of images off if you're on like a mobile network can be really pricey. But these profiles are pretty lightweight, so passing them off on like a mobile network usually isn't a problem. I don't know if that answered your question, Kevin, but if you have any more specific stuff around computer visions and you want to tell me more about your task, I'm always happy to learn more, especially around computer vision, because I love computer vision. Someone said, pretty cool, trying to catch up to get the meaning of a data drift detected plot. So in this case, we configured a monitor, and I can go through that again real quick. But this plot, so we have this new purple line. And by the way, you can turn these on and off if you want. So if you wanted to just look at the purple line or something, you can. And what this is telling us, based on that distribution metric that we picked, which was Hellinger distance. Again, there's several others you can pick, but kind of recommended you just start with Hellinger unless you have a specific data type a different one is going to work well on. This is just saying that, this data on this day had a large drift value. And that drift value was calculated between the difference of, in this case, we're using a reference profile. So it's actually looking at the training data. And this new profile on this day is saying this data looks way out of bounds from what we were trained on for a machine learning model. If we did it like before, where we were looking at those past 7 days, or just, we know that this other past day, the data is actually pretty close to the training data. So for instance, we can look on this day, we see the min, the max, the median. There's the other values there too. But they're all like this 4.2, 4.3 range. Max is somewhere between, 6 and 7, and a minimum is, I don't know, nowhere below 0.9, but maybe not above 1.2 or something like that. On this day, if we look at this value, just manually looking at it, we can see the median went way higher. It's 9.2. The max is 11.8. And the minimum is 6, which is way higher. In this case, everything is way higher. And so it detected, hey, this doesn't really match the other data that I was, in this case, the model was trained on. Something looks different here. And so it calculates a drift metric based on Hellinger distance. And then that's what we're seeing here in this kind of purple bar, this really high value there. So it does it for all those 3 days. Someone said, very useful. Follow till the error in the logging output in the notebook. Be interesting to see what the error is. Maybe I won't be able to troubleshoot it all here. Usually if there's an error, and I don't know if this is your case, often when it happens, it might be that you accidentally skipped a cell. It looks like that one you might, or someone else also posted an error. That's a little bit later in the section. And potentially you didn't update the new model or something, because it looks like you're running the segment piece that we'll get to. So I'll run through the code. Great questions, everyone. And someone said they followed until the error and the logging performance. Just make sure that you didn't accidentally skip one of the code cells. Most of the time during the workshop, if everything else was working fine, and then one part of it didn't work, it's often, and I do this when I run it, and I'll be like, oh no, what happened? Oh, I didn't run something that logged the value. So that might be what happened. And then someone posted an error that I think is later down in the notebook. I'm going to go ahead and run that part, and I guess we'll see what happens. Someone said they got a value error for it. The feature names unseen at time. One thing I know too is if you run part of the code and then run back, because we edit the data frame, it might have an extra thing in there. You can always hit restart runtime or disconnect and delete runtime and go through all the steps again if you want. And hopefully it would work for you. But kind of weird because I didn't get that error. But I'm going to go ahead and I'll run the rest of it because I know someone was posting about that. And I'll see if I can help you there as well. Or again, maybe you accidentally skipped a step here. But yeah, if you do get an error and you want to reset, you can always go to runtime, because disconnect, delete runtime, and then run all those cells again. Or if you already have the YLabs values in there, you can actually hit restart and run all, and that'll run all the code cells in order, and hopefully that would fix your error. I'm guessing it's something of like running something not in order in this case, because I just did it too and we didn't get that. All right, so let's go on to the next section here. Thank you for all the questions. Again, feel free to keep asking them in the chat. If I don't get to them right now, I'll hopefully have time at the end, but also connect with me on LinkedIn or join that Slack channel and ask them again there. All right, so we're going to do part 2 of this. We're going to be doing some of the similar stuff, except for we're going to be looking at some other features. Our data is going to be a little bit different, and we're going to be figuring out how to monitor kind of for the bias and fairness, like I'd mentioned, like in that credit card situation. And then we're also going to be looking at how we can log some of those explainability values and gain some insights from that. So let's go ahead and import everything. This is going to be very similar. This first part is going to be very similar to the stuff we did. So I'm going to run through it very fast. We're just importing the libraries that we're going to use. Again, our iris data set. Our production iris data set is going to be a little bit different this time, though. We're going to train a model exactly like we did before. It's a k-nearest neighbors again. All right, and then we're going to import those CSVs. Actually, these are slightly different CSVs because we're using new data. We're going to be looking at a new problem here. But it's the same thing before where we imported these 7 CSVs, and then we're creating a data frame list here. And then I can look at that, and we'll see that this is very similar to the data that we looked at before, except for it has a new value here called state. So we have 3 states that our flowers belong to now: Washington, Missouri, and Florida, I believe are the 3 I have in there. And again, we're going to create a profile just like we did before. We're going to view that profile and we can see what it looks like. Very similar to before, except for, again, we have the state and we can see that there's, cardinality of 3. So there's those 3 values I had mentioned: Missouri, Washington, and Florida in there. And then we have our profile statistics, just like we've seen, very similar to the other profiles so far. So again, we already looked at how to write the data up for a drift. Oh, cool. Someone said restarting the runtime fixed the error. Awesome. Yeah, no worries. Again, like I was saying, I do it too. I'll run something out of order somewhere. Totally happens. Thank you for trying it out too. All right, so we already put in our org ID and our API key. What I want to do is I am going to put a new model ID in here. You could try uploading this to the same model, but it wouldn't. It's not going to be as fun to troubleshoot the stuff that I'm going to show. So go ahead and go back to the YLabs platform. We're going to create a new resource again, and I'll just call this explain, but again, you could call it something way more meaningful. And then again, I am going to select classification model. Again, if you don't do this, when you look at performance metrics, some of them, it won't show up correctly or won't calculate them by default. So here we're going to add the model, and now I have this explain one, model 243. So I'm going to copy that value just like we did before. But this is the only one I'm going to get because we had already set our org ID and API key earlier. So those values are still in our notebook. And I'm just now going to update the model ID. So I'm just uploading to multiple models here from the same notebook. So go ahead and run this. I will give everyone a second to do that because, again, I know I can go pretty fast through the platform sometimes. So you can go to YLabs again, hit that create resource, type in a new model name, and then copy that number over. I'll give everyone a minute to do that. And then just paste it over there. Again, make sure there's no new lines or spaces involved either. And just reiterate, writing a single profile is just a couple lines of code. But in our case, we are going to kind of loop around again simulating our model being in production. So here, I'll go ahead and run this. This is creating a pandas data frame with, basically, we're just doing it all at once in this case, or we're making one giant data frame, and then we're going to upload all this data. But we're going to upload it with segments. So that means we're going to be able to view our data, breaking it down by state. So in this case, we're looking at flowers by state, but this really could be anything, right? Like I could mention a gender issue with credit card approval. So you could have that as a feature that you add into your data here and then be able to break it apart on it. So now let's go ahead and upload our data. Very similar to like we did before. We're looping through. The biggest difference here is we're importing this segment on column from ylogs. And then we're passing in the column that we want to segment on, which in this case is state. So it can take just a little bit longer because it's segmenting up the data, and then I'll write it. And we can also go ahead and run the code cell below this time, so I don't forget, which is a reference profile. So if you want to set a monitor on a reference profile, you can. And then let's actually, I'm just going to go ahead and run through a few more code cells here before we get to the platform. But that already uploaded our data. We're going to do the same thing for performance metrics, kind of like we did before as well. So we have the ground truth, and then we're just going to log that up. But again, the big changes here is we're using that segment on column. So we can actually break down our performance by a segment as well. And then I'll stop here. We'll come back to this feature importance in a minute. And that's still uploading, but we can go to the YLabs platform. Again, I'll go back to the homepage here. And now we have our new model, explain. So I'm going to go ahead and click into this. Also, you can always click in down here, and this will make sure that it does align the dates with your profile lineage. It looks like we already are, but just as a quick note, you can click that. We get some cool metrics here about our latest accuracy, etc., for all the profiles we've uploaded. And I didn't go to this page before, but we can explore each individual profiles. So you can look at these batches. You could look at the reference profile, and you can get some fun statistics about them just in here as well. And for some of them, you can set up insights that will be generated, like in large language models. But let's go back to the input tab. Petal length, just like we looked at before. Now this data looks a little different though. All of our production data in this case, eyeballing it, and because I know the workshop, like this looks pretty even. It's not like I see anything clear, like a big drift that's going to be happening. So it can be really hard sometimes. Well, in this case, like if we set up a drift monitor just on all the segments here, we wouldn't be able to really catch if, in our case here, catch a change that is kind of hidden here. We're going to figure out how to find that hidden change. So one thing I like to do is we have these segments. You can go to the segment tab. Now you can click in and you can actually see, what this data looks like for each one of those. So state Florida, state of Missouri, state of Washington. And we could visually inspect all of these kind of like we did manually before. But that's a lot, especially if you have a ton of different segments. Like we could go through 3 and compare those values, the min, the max, etc., on all of them. But that's kind of a lot to do, especially if you have more than 3 values. Like often you might have like 20 segments or more. So we can go to this tab here called tracing. And hang on one second. Let me refresh. There we go. All right. So if you didn't have this other chart, you should be able to refresh and it should show up. I think the metrics are still uploading there. Or they just finished uploading before I refreshed. So here we have this tracing tab where we can select these 2 different metrics that we want to look at our segments on. So in this case, I'm going to go ahead and choose accuracy and F1 score, but it could be any of those kind of classification metrics that we had. And now we got this kind of easy way to visualize how they perform on each segment. So in this case, like let's say for our model, we're basically required to have at least a 90% accuracy across all segments. And in this case, Florida actually is below that. It's at 80%. And it was really hard to see, what was going on with the inputs unless we could separate it out like this. And this tracing tab gives us a visualization to really easily see kind of like almost like a needle in a haystack of a problem between our segments. And you can choose all the different ones. You want to look at recall. So you have these bars that kind of visualize it, but you can also hover over it and see the actual values for accuracy and recall. You can also compare profiles on individual days. So maybe one day was really good or not so good. So for Florida, it's all about the same. And it was interesting is on this particular day, maybe it doesn't really matter for our model too much, but on this particular day, Florida actually accuracy is pretty high and Washington was pretty low. So again, you could take all this findings and go look at your data, see what's going on. And again, maybe you want to retrain your model in this case for like, oh, like our performance just isn't as good on the Florida data set. Maybe it's because our training data didn't have that many examples in there. And we want to retrain our model with the newly collected examples. And now that we have the segments, you can also go to this performance tab like we saw before. And we can compare like all data compared to a specific segment. So in this case, selecting Florida, we can see the accuracy was well lower than all data. You can also compare a specific one. So how is it compared to Washington? Much lower, et cetera. So this is a really cool way of being able to easily like drill down how your model is performing on specific segments or groups that might be in your data set while in production. What does everyone think of this? Seems interesting? Seems cool? Do you see value probably in doing this if you have specific segments in your data set that you want to make sure it's actually performing well on? Or maybe you're adding new segments to your data set, like you got a new customer, maybe you didn't retrain a model yet, but you want to go ahead and deploy that model out in that environment. And you can have that as a new segment, see how it's actually performing there, collect that new data. And, again, seeing that performance is lower in the other ones, you could take that new data and then retrain a model, train a new model, deploy that model, see how that new model is working against the old one. And then if it's working better, go ahead and deploy it out. I think it's really neat that you can have all these things like that could tie into your whole MLOps process. Any questions so far on this? Otherwise, I'm going to go ahead, go through the next section. Again, feel free to ask questions in the chat as we go. And I'll go through this. This section actually is going to be pretty quick. And then we're going to look at a few more open source features with YLogs, like setting those unit tests for your data. So let's go ahead and pip install SHAP. This is what we're going to be using for getting those feature importance. Kind of like if you were here at the beginning, we looked at what that might look like in some of the slides. It's a really cool library for getting feature importance. If you haven't looked at it, definitely recommend checking out the GitHub. Actually, maybe I'll pull up the GitHub real quick just to show you. So it has a lot of cool built-in tools for getting feature importance. We're going to be using on tabular data today, getting something like this, saying like, oh, this particular feature, in our case, it's the ones in the Iris data set. So it'll be looking at like pedal length, et cetera, which one is probably making the most important for the model making the decision. But you often have more features than 4. And so it's kind of cool to get inside of like what is causing your model to make a certain prediction or not. But it also has a lot of cool features around not just tabular data, but transformers, for example, and natural language processing, computer vision. So if you want to have it kind of highlight the parts of the image that, again, is causing the model to make, predict that it's a 9, et cetera. It's a really cool way of gaining understanding about your model. Like, why is it doing this? Like, this is a really cool example. Looking at this bird, why is it predicting a bird over like a meerkat? Well, this beak looks like it's probably the most important feature. And then for a meerkat, it's eyes. And it's often what I've seen when you're doing animal stuff, like you think it might be the ears or something on it, like for a cat. And often from what I've seen and just my experience anyway, often it's like around the eye area. It seems to be really what the model picks up on a lot, which is pretty interesting. Someone said, with the SHAP library, can I also explain the values predicted in the new data? So that's kind of what it does a little bit here. So in this case, like classification, for an image, it predicted a meerkat, and this is kind of why it's highlighting the most important pixels for that classification model. And then, yeah, if you were on a tabular data set, like the housing price one here. This is kind of what we're going to be logging today. So it's just saying, well, this one, I forget what LSTAT is. It might be a tax bracket or something for houses. And then there's like number of rooms. So basically saying like this was the most important feature of why the model made the prediction in general. So there are ways to do it on individual predictions. We're going to be looking at kind of overall important features. So today we'll be looking at basically this is like looking at a test data set. These were the most important features to your model. But you can, I think with SHAP, dig down and do it on individual predictions as well. So go back to my copy. We'll import SHAP now. We're going to import a SHAP.explainer. We're going to pass in our K-nearest neighbors model and our training data set. And then basically it's going to run some tests on our test data set that we had separated out before. SHAP does a lot of stuff behind the scenes, a lot of mathy stuff, I think including some game theory around like making predictions and figuring out what the values are that makes the most important, or what values are most important to your model. So here we have this little summary plot here of just what we got for, again, we just had those 4 values, and based on the info that we got from SHAP, petal length is by far the most important factor. So we might even be able to remove these other features and just make predictions based on that one feature. And I haven't done this on the model, but just theoretically, our model could still be maybe as accurate, or maybe just with these 2 features. So it turns out sepal length and sepal width aren't really that important in this case to our K-nearest neighbors model. So we're going to go ahead and put this kind of in a dictionary format here. You can log any type of dictionary format like this. So here it is. It looks like we got the feature name, and then we have the SHAP value tied to it. As long as you can get it into this type of format for your global feature importance, you can log this up to YLabs. So again, we'll call this, we're importing feature weights, YLabs writer like we did before. And then we're calling writer on the feature weight, similar to like we did with profiles. And if we go back to the platform, now I go into this explainability tab. Might need to refresh. Yeah, should be written up, I think. I'll give it a second to populate. Make sure I did it in the right model. Did anyone see? Did I do something stupid? It's very possible. Did it work for anyone else if they were actually running the code? I am guessing that I messed up with my code somewhere. Like someone else had the issue earlier. It's usually me doing something wrong here. I'll try running this again. But yeah, someone said it worked for them. So again, it's me. What did I do? I will have to check this out later, probably too. I don't want to spend too much time troubleshooting this for anyone. I might take just a second more. But yeah, so you should have, someone said it worked for them, which is great. It's supposed to. You'll get a little chart that looks like exactly like we had here. And then that's logged in YLabs, and then when you click on it, it'll take you directly to that feature. So it's a really cool way of just kind of having your global feature importance. And then again, we only have 4 values, so it might seem like not super valuable maybe in this case, but if you had like 20 or 100 different values there, what you might want to do is set up different monitors on these specific features. So if petal length is by far the one making the biggest difference, maybe we want to make that monitor more sensitive, and when there's a change to that a feature, we want to have an alert happen, and maybe we want to kind of adjust it for the other ones. So if it actually showed up in your platform, you should be able to have this and then click on it, and it should work. I don't know why it didn't show up for me, because I also just ran this notebook right before I did the workshop, making sure everything works, and I'm sure it's me. I don't see what it is, but it's probably me missing something here. But yeah, I won't spend too much time on it. It's a cool feature where basically that graph is logged here, and then you can click into those features and kind of see which ones are the most important. Or right, like you might have teams operating on things. Usually it's not just one person in a company. So you can run this kind of SHAP value report or global feature report and then have that logged for anyone else looking at your data and models over time. Someone said, does the SHAP value correspond to understanding black box models in neural networks? So that's kind of, I already closed it, but I think, yeah, like the use case of understanding why a computer vision classifier classified that as a meerkat, not a mongoose, that gives you some insight to it. So there's a really good book that just came out. Actually, I know the person, he's in Seattle, who wrote it, that I think is just called Explainable AI. And it's an O'Reilly book. It's pretty new. It came out this year. So it has like up-to-date technology. If you're looking to learn more about explainable AI, definitely check out that book. It goes in depth into a lot of the different ways of doing it. Like we had showed, if you're here at the beginning, like here, it's giving just kind of highlighting the areas that it thinks is most important for classifying elephants in this case. There's a lot of different ways of doing this for, again, like computer vision, tabular data, transformers. Go check out that book if you want to learn more about the explainable AI field. It's really neat. And it dives deep, like I was saying, into all the major use cases like computer vision, NLP, tabular. So I'm going to go ahead and move on. I know the explainable part worked for other people. I don't want to spend too much time troubleshooting here. I'm going to go through this last part probably pretty fast too, just to make sure that we kind of wrap up at a good time. These next parts is just going to be using YLogs, just that open source library, and we're going to be doing stuff with it in our local Python environment here. So far, we've kind of been looking at writing these profiles, creating these profiles, and then writing to them to YLabs to visualize and set alerts there. That's really cool and super useful. We're going to look at some potentially useful components of just using YLogs in your Python environment. So let's look at how we can get some data drift metrics between a couple profiles locally. So this doesn't have the capabilities like in YLabs where we had that time series view of like 7 different days, visualizing all of that and setting monitors on it. But if you want to do a quick check between like one profile and another, has really good built-in capabilities for that. So let's go ahead and create all these batches of our data. And as we go through, I encourage you to change, like you'll see here, it says profile view 1, profile view 2. You can change out that 1 and 2 for any of these values between 1 and 7 and kind of see what happens here. So here I'm going to call this notebook profile visualizer from YLogs, ylogs.viz. We're going to initialize the notebook profiler, and then we're going to view the difference between profile 1 and profile 2. So again, you could change these out for these other values and see what happens. Run that, run this visualization.summary drift report, and this is going to generate a little report that we can have in our notebook here. I'm zoomed in, so it's off the screen a little bit here, but we can see that gives us the total count for all the rows of data in there. And then we have this column here that says, was there data drift detected or not? And then it gives us some drift score. So before we looked at Hellinger distance, by default, the value in YLogs is KS test. But again, you can overwrite this, and there's a link, and I'll show you a little bit later. You can change basically what counts as drift and what doesn't count as drift, and which drift algorithm to use here. You get a little report of our visualization of what the distribution looks like between the two profiles as well. So let's scroll down, and let's drill a little bit more into this, though. So let's look at just the petal length or width was the first one I did, and see how those two profiles distribution overlay on each other. So we can see they're very similar. We have one profile in blue, one profile in orange, and we're kind of overlaying them to see like how similar are they. And you can see they're incredibly similar. The distribution doesn't fall very far outside of each other. Let's look at another one, petal length. Again, same here. It is kind of high here, so like that's interesting. That probably triggers some of the drift metric, but again, it wasn't enough in our case here to trigger the auto drift detected configuration. So again, let's do this for, before we do another profile, let's look at actually all the scores so you can get them all in a dictionary format here. So if you want to do anything based on these values, you can extract them from this dictionary. And then the link is just down below here, you can hit drift algorithm configuration. So basically, you can configure everything that's going on in here. So a lot of customization you can do in YLogs, which is cool. But let's look at 2 more profiles compared to each other. We're going to look at profile 1 versus profile 3. And again, remember, we're calculating this drift distance by looking at one profile and then comparing the distribution of these features against each other from those 2 profiles. So we can see this first one, no drift detected. Drift detected here, which is on our sepal width. And then pedal length and width, no drift detected. So we can scroll down. We can look at pedal length. And we can see that, distribution is pretty similar. What was the one that actually had drift detected, though, was sepal width. For some reason, I should have had this in the notebook here so we could see the drift, but I had pedal width. So I'm going to change this out to sepal width. And we're going to overlay those histograms on each other. And we can see the distribution, it looks somewhat similar here, but it is a little bit more like this orange profile falls out of the range of where the blue one is on both sides, actually. So that's like enough to say, in our case, how it's configured, that, hey, this profile distribution is different enough from the other profile that you told me to look at to trigger an alert, basically. And again, we can get those raw metrics in a JSON format here, so you can actually do something with them in your local environment. All right, and one more thing. Again, I apologize if we're going pretty fast through it, but I just want to make sure we all finish on time. We're going to look at data validation with constraints. So remember, we saw data drift happening sometimes because the values were like way out of bounds, and it seems kind of ridiculous. Like if we know an iris pedal shouldn't be 33 centimeters, then that should be flagged earlier on, so you can actually do something called data validation with constraints in YLogs. This is kind of like writing a unit test for your data. So this is a little, picture of new data coming in, and maybe we're saying that, no data should be null. No data should be a negative number. Like again, if we were doing pedals, the pedal can't be a negative number, so we know that's some sort of data quality issue. So basically, we're writing a little unit test for our data. And we can do that with constraints. So we'll go ahead and import these constraints and metric selector from YLogs. And then I'm going to go ahead and run this, and I'll talk through it here. Each one of these little clumps of code is us building an individual constraint, and we're doing one for each feature in this case. But you could add a whole bunch. You could do multiple ones for each feature. But in this case, we are just going to be looking at each one, so like pedal length, etc. And we're going to say it should be greater than 0. So no measurement should be 0 or negative number. And that should always be below 15. Anything above 15, that flower doesn't exist in this case. Like that should be flagged in our environment. And so we're targeting that as a distribution metric. And then we're getting that min-max value that was in our profile before. So we initialize the constraint builder up here. And then we're building each of those constraints here. And then we just call this builder.build. And let's run this. And then I'm going to pass in profile 2 here. And I get this little report. And we'll actually see how to visualize this a little bit better in the next code cell. But we can see this is our test that we wrote. And by the way, this part can be any string you want. I tend to just write out what the actual test is, but you could give this test a different name. And then if it's a 1 here, that means it's passed. And if it's a 1 here, that would mean it failed. So in case of 4 things, it's kind of easy-ish for us to read this maybe. But we have a really cool visualizer built for this as well, where you can get this whole little report. And again, we only have 4 values here, but you can imagine if you had like 20 or 100 different values, this could be really neat to have this report of seeing which one's passed, which one's failed. You get some information like when you hover over it. And you can also search and filter right in your notebook as well. So a really cool way of generating reports for these tests for your data. So also, there's a built-in function here just called validate. So you can run your constraint report, and then you can call .validate on it. And it will return true if they're all passed, and it'll return false if any of them did not pass. So really useful, like this is great to look at. But if you're actually writing a unit test to do something in your Python environment, you can use this validate method, and then that'll just say true, yes, everything passed, or false, something failed, trigger something, right? Maybe that's stopping some sort of build or something like that in your pipeline. So let's do this again with a different profile. This is profile 4. Quickly looking at this, we get the report. We can see one failed here at least. And I'll go ahead and run the visualizer. And we can see that one failed. And in this case, it's the pedal width failed. And I think if we look at that profile, pedal width, we can actually just look at these metrics even. And let's see, it was the min or max. Oops, I skipped it. In this case, the profile had one that was 0. So there was a data set in there, or at least one row of data had zeros. And so that's kind of all the plan stuff I was going to show you with YLogs and YLabs. We went through a lot today, so you should be proud of yourselves for sticking around. There's still quite a few people here, which I'm pretty excited by. So there's a lot more links as well if you want to. One, you can click this link and request a certificate for attending the workshop if you'd like. There's always more upcoming events. I also do a lot of interviews with industry experts, so I bring them on, talk about like, what have you learned about putting large language models in production? Or we're doing one on computer vision soon as well. Actually, 2 on computer vision. One is computer vision only, I think, and one's computer vision with LLMs, which will be exciting. There's a lot of examples in our GitHub, on our blog. You can also join the Slack group, and then just in general, you can go to ylabs.ai and find everything there. And I think I saw some questions come in, so I'll be looking at those. But also, please feel free to ask questions in the chat. I'll be hanging around just for a few minutes, and I'll see what everyone says. And then if you want, please join that Slack channel. Ask me questions there, especially for anything specific. I know someone was talking about a computer vision use case, maybe a large computer vision use case. I would love to hear more about that and any challenges that you're having there. And hopefully I could help you. I mean, I know we went through this last section pretty fast, so if anyone has any questions there too, please let me know. And then I'll also share this form one more time. If you want to fill out, get some swag. Super simple. I think there's just 2 questions, basically. Basically, it's a swag form. So if you want to fill that out, and I think we right now are sending it to like up to a couple people that fill it out, 5 people or so. So not everyone who fills it out will get something right away, at least. And I'll get to the questions in a second. I'll also just share my LinkedIn link if you want to connect there. But I recommend the Slack channel if you want to ask questions about product or anything. We also have, other ML engineers from YLabs and people outside of YLabs in there, and data scientists. So if you have any other specific questions around anything, that's going to be a good place for it. Someone asked for Colab and YLabs. Do you need a license? You should just be able to create the YLabs account. And I don't work for Google, but I don't remember what their policy is for everything in their Colab environment, but I think it's pretty open. You should go check that out. I know they limit some things to like image generation and stuff, I think, in there. So I think it depends exactly on what your work is. And for YLabs, if you went through, we have those couple free models that you can get started with in the free tier. And then if you want to move into using more models and some of the other features, let us know. Someone said, nice workshop. Great job. Thank you so much. Always glad to hear when someone said, it was a good workshop or they enjoyed it. And yeah, so did anyone learn anything new? Did you find it interesting? You must have found it pretty interesting to sit through for almost 2 hours. Someone said, amazing job, Sage and YLabs team. Thank you. Yeah, again, and thank you so much for everyone attending, taking time out of your day, attending a virtual webinar. I'm excited that in-person stuff has been happening a lot more too. I love online because I can reach so many people in different places like we saw at the beginning. People are watching from all over. But I'm in Seattle, and yeah, there's just been a lot more in-person stuff popping up. I know if you're in the Bay Area or New York, I think you've had in-person stuff going on a bit more for a while now. But it's really exciting. Like I was at several events this week already. I spoke at a Google I/O event on Monday. There was over 200 people there. It was really awesome. Oops, that's a weird layout. Any other questions before I wrap up the live stream? And again, like I said, you can connect on the Slack channel, ask questions there later. So definitely don't be shy. Like if you didn't have a question right now and you might have one later, ask it there. If I missed it, I think I got to all of them, but if I did miss it in the chat, I didn't mean to, and you can re-ask it in the Slack channel. Is anyone going to try and use some of what they learned today in a project or at work? I know, and I'm somewhat biased because I work with it all the time, but I've definitely been implementing like ML monitoring stuff more in like hobby projects even too. And you learn a lot about your model. So if you train a model and put on a Raspberry Pi or something like that, and you want to keep looking at the data that you're collecting, it can be pretty interesting. Someone said, can I please post the link for the certificate? Yeah. In fact, I think I usually do that and totally forgot. Sorry. And this, I think we make right now. So hopefully I'll get it either later this week or probably sometime next week or something. But yeah, fill out the form. Oops. That is what is that? A Colab redirect link? Let me. I'm not sure if that worked. I mean, it looks like it might have. It was a redirect link, but here is the form again, if you want to fill that out. What a cute dog. Oh, you can't see. Sorry, I stopped sharing my screen, and there is a Colab link, or like when it was doing the redirecting, and it had this really cute dog walking by. So, not a real dog. So they'll take a bit of time to try it out, but it definitely seems worth it. Yeah, I think so. Especially depending on your application, but monitoring is definitely, in my opinion, pretty important. Even before I worked here, it was something I would do all the time with different projects, because if you didn't, something always goes wrong somewhere, and it's way better usually to catch it. Someone said about a certificate for other workshops if they're there. Feel free to, if you join the Slack and ping me there, I can probably get that sorted out for you. And I'll post the Slack link one more time as well. Oh, it's doing that weird redirect link again. I think that's a newer feature, because I don't remember this from a while ago. I used to copy all these links out. It makes sense. Yeah, so you can join the Slack there, ping me on there, and we can sort out any certificate thing. And also, totally recommend checking out the GitHub repo for our large language model monitoring. There's some really cool stuff going on there. I'm excited to do another workshop on that soon as well. So if you follow us on Eventbrite or Meetup, you'll probably see that posted today or tomorrow. And I think it's really fun to go through. And we actually will take a large language model from like Hugging Face and then learn how to implement monitoring on it. And it's a little bit different than doing tabular data. So basically, or if you're using like OpenAI, you're basically just getting prompts to your model and then responses. And a lot of people change system prompts over time. So you want to have monitoring implemented there to see, are you actually improving your model with those prompts or not? It's pretty interesting. All right, if there's no other questions in the chat now, like I said, feel free to join the Slack, ask me questions there or on LinkedIn. I'm going to go ahead and wrap up the stream, and then hopefully I'll talk to some of you all later. And I'm glad people enjoyed the workshop, and I'm excited to see, you implement some of the stuff you saw today, probably in projects. If you have questions about that, please reach out to me. And have a good day, everyone. I'll talk to you all later, or at least some of you.